of computing that already we discussed in the previous presentations. The second one is types of soft computing techniques. Okay, what are the different types of soft computing techniques? Okay, that you should be very perfect on these two. Introduction to soft computing, types of soft computing techniques. The third one is introduction to artificial neural network. You should be very perfect on that. We should be very perfect on the supervisor learning network one. Okay. The next one is in sequence. This is a sequence of this. Sequence of innovative presentation. I am doing working practically now. That's why I am giving a practical oriented presentation. Next one is the supervisor learning of network 2. Okay. And associate memory network. Okay. And associate memory network. Supervising learning network 1. Supervising again. I am measuring on the network 2. And associate memory network. Next, what about unsupervised learning? We should know about the unsupervised learning. Okay, unsupervised learning. What's the meaning of unsupervised learning? Okay, the next one is special networks. You should know about the special network. Okay, so unsupervised learning. You know about what is unsupervised learning. Okay, and special networks. Okay, today I will highlight our special networks. Special networks. Okay, the topic I will directly go to the special networks. It's very interesting. This explanation is more than enough for you. You can easily understand what is special networks. I will go in a practical oriented of presentation about the special network. Special networks is concerned. Objective one is a simulated annealing network. Simulated annealing network is one of the special network. Okay, simulated annealing network. Simulated annealing network. Okay. This is the first topic here is the first topic here is simulated annealing network is the objective one. Objective two is Boltzmann machine. Objective two is Gaussian machine. Objective four is okay Cauchy machine. And objective five is probabilistic neural net. Okay, objective six is cascade correlation network. Seventh objective is cognition network. Eighth objective is okay neo-cognition network. Ninth is cellular neural network. 10th is optical neural networks. The 11th is third generation networks. The next one is the 12th is encoding of neurons in SNN. And the 13th one is CNN layer sizing. 14th one is deep learning neural networks. Extreme learning machine model is the 15th one. First, I will go to the simulated annealing networks. The concept of simulated annealing has its origin in the physical annealing process performed over the metals and other substances. In metallurgical annealing, a metal body is heated almost to its melting point and then cooled back slowly to room temperature. This process eventually makes the metal's global energy function reach an absolute minimum value. If the metal's temperature is reduced quickly, the energy of the metallic lattice will be higher than its minimum value. because of the existence of the frozen lattice dislocations that would be otherwise disappear due to thermal agitation. Analogous to the physical annealing behavior, simulated annealing can make a system change its state to higher energy to state having chance to jump from local minima or global maximum. There exists a cooling procedure annealing process such that system has higher probability of changing to an increasing energy state in the beginning phase of convergence. Then as the time goes by, the system becomes stable and always moves to the direction of decreasing energy state as in case of normal minimization produced. With simulated annealing, a system changes its state from the original state SA old to a new state SA new with the probability P given by P is equal to 1 by 1 plus exponential of minus delta E by T, where delta E is equal to E with a probability P is given by this formula P is equal to 1 by exponential of minus delta E by T. Okay, so that is the formula. It's a probabilistic estimation. P is the navigative parameter. Okay, so and delta E greater than equal to 0 is always higher than the probability. Delta E less than 0 for any temperature. For optimization problem, seeks to find some configuration of parameters that minimizes some function f of x called cost function. In an artificial neural network, configuration parameters are associated with the set of weights and the cost function is associated with the error function. The simulated annealing concept is used in statistical mechanics and is called Metropol's algorithm. Simulated algorithm uses the algorithm which is called Metropol's algorithm. So as discussed earlier, this algorithm is based on a material that tends into a solid as temperature. It slowly decreases. To understand this, consider the slope of a hill has a local values. A stone is moving down to the hill. Here the local values are local minima and the bottom of hill is going to be the global or universal minimum. It is possible that stone may stop at local minimum and never reaches the global minimum. In neural nets, this would be correspond to a, just the important logic correspond to a set of weights that corresponds to the local minimum. But this is general the desired solution. Hence, to overcome the kind of situation, simulated annealing for uh, the stones such as trap the local minimum. It escapes it and continues falling till reaches the global minimum. Optimum solution. At this point, further propagations cannot move to the stone to the lower position. Figure shows the simulated annealing between a stone and a hill, like this. Simulated annealing stone, there is a graph. Okay, what are the components required for annealing algorithm? Here you should know about annealing algorithm. This is a practical application. మనం ప్రాక్టికల్గా అప్లికేషన్ తీసుకుని దాన్ని ఎన్హాన్స్ చేసేటప్పుడు అనలింగ్ అల్గారిథమ్స్ మనం యూజ్ చేస్తాం. అనలింగ్ అల్గారిథమ్కి చాలా యూస్ ఉంటుంది యాక్చువల్లీ. ఓకే, అనలింగ్ అల్గారిథమ్ హ్యాస్ లాట్ ఆఫ్ యూస్. ఓకే, practically it has more and more use అనలింగ్ అల్గారిథమ్ హ్యాస్. ఓకే, సో మన ఒక అప్లికేషన్లో పర్టికులర్ అప్లికేషన్ అల్గారిథమ్ వాడి we will write some code, we will develop some code, we should change something on the system using the annealing algorithm. Likewise, the first point in the annealing algorithm is a basic system configuration, the possible solution of a problem over which we search for a best optimal answer. Okay, the move set, the second one is a set of allowable moves that permit us to escape from local minima and reach all possible configurations. A cost function associated with the error function, a cooling schedule. Okay, Okay, starting of the cost function and rules to determine when should be lowered and by how much when annealing should be terminated. Simulated annealing networks can be used to make a network coverage in its global minimum. Okay, what are the requirements series? Basic system configuration, the move set, cost function, cooling schedule. The early optimization technique is used in artificial neural networks is based on the Boltzmann machine. When the simulated annealing process is applied W to the discrete Oakfield network, it becomes a Boltzmann machine. The network is configured as a vector of the states of the units, and the states of the units are binary values of the state function. The Boltzmann machine described in this section fixed weights. Boltzmann machine to a constant optimization problem. The weights represent the constraints of the problem and the quantity to be optimized. Okay, the discussion is based on the fact of innovation consistentness function. In short, it is called CF. The Boltzmann machine consists of a set of units, Xi and Xj, and a set of bidirectional connections between pairs of units. This machine can be used as an associate memory. If the units you just understand all my practical concepts and practical testing, they are interesting. When నేను ప్రాక్టికల్గా వర్క్ చేస్తున్నాను కాబట్టి మీకు ఈజీలీ అండర్స్టాండ్ అవుతాయి. బోల్జ్మన్ మెషిన్స్, ఈ అల్గారిథం, నేను చెప్పే అల్గారిథం. ఓకే, ఫస్ట్ ఇవి అండర్స్టాండ్ కాన్సెప్ట్స్ అండర్స్టాండ్ ఈ విధంగానే చేసుకోవాలి. నెక్స్ట్ ప్రెజెంటేషన్లో నేను ఇవన్నీ పిక్చర్గా చూపిస్తాను మొత్తం అని. దెన్ ఆబ్జెక్టివ్ ఆఫ్ న్యూరల్ సెట్ ఏంటి, how to maximize using the conscious function, neural set ఎట్లా maximize చేసుకోవాలి, neural to ఎట్లా minimize చేసుకోవాలి, set of artificial neurons. Okay, this artificial neurons is developed, the basis is our brain neurons. మన brain neurons is the main one. దాని బేసిస్ తీసుకుని మన ఆర్టిఫిషియల్ న్యూరాన్స్ డెవలప్ చేసుకోవచ్చు. ఎలా డెవలప్ చేస్తాం, how we develop artificial neurons based on the main brain function, how the brain function is. Artificial neurons function typical గా కాన్సెప్ట్ ఇప్పుడు నేను చెప్పేది విందాం, నెక్స్ట్ క్లాస్ లో గ్రాఫికల్ గా చూద్దాం. అది మన ఎయిమ్ యాక్చువల్లీ. అలా ఫాలో అయితే మనకి నాలెడ్జ్ రావడానికి ఛాన్సెస్ ఉంటాయి. ద మాక్సిమం ఆఫ్ దిస్ కన్సిస్టెన్స్ ఫంక్షన్ ఈజీగా అర్థమవుతుంది, కెన్ బి అబ్టైన్ బై లెటింగ్ ఈచ్ యూనిట్ అటెంప్ట్ టు చేంజ్ ద స్టేట్స్ 1 to 0, 1 and 0, and 0 and 1. The change of state can be done either in parallel or sequential manner. Just try to understand. This change of state from 0 to 1 or 1 to 0 can be performed either sequentially or parallelly. So, however, all the descriptions is based on the sequential manner. The consciousness change, when Xi changes in a series, change is nothing but delta always. The change is represented by delta. Okay, 1 minus 2xi wij plus sigma j equal not equal to I wi xi. Change is always delta. Xj is the current state of the unit capital Xi. The variation coefficient is given by +1 when Xi is currently off, -1 when Xi currently on. If unit Xi are to change the activations, then the resulting change in the consciousness function can be obtained from information that is local to unit capital Xi. Really, Xi does not change its state, but if the states are changed, then increases consciousness of the net. The probability of the network that accepts the change, okay, is given by the function. Okay, it is some formula. The architecture of Boltzmann machine is very, very important. It's a very simple graph, of course. Okay, that one diagram architecture of the Boltzmann function. Okay, testing that Boltzmann machine algorithm. Boltzmann machine algorithm. What are various steps? Every class మనం presentation లో చూస్తున్నాం steps. Step 0. Initialize the weights representing constants of the problem. Also initialize the control parameter t and activate the units. Step 1. When stopping condition is formed, false. Perform steps 2 to 8. Perform steps 3 to 6. N square times. Okay. Integers I and j are chosen random values between 1 and n. Calculate the change in consciousness. These are the algorithm steps. Okay. Step 5. Calculate the probability of acceptance in the change of state. The step 6 is decide whether to accept the change or not. Let R be a random number between 0 and 1. Step 7. Reduce the control parameter capital T. Step 8. Test for stopping condition. Step 8 is step for stopping condition. Gaussian noise. Gaussian machine. Gaussian machine is one which includes Boltzmann machine, co-fill net, and other neural networks. Gaussian machine. Next important topic is Gaussian machine. Is one of the which includes Boltzmann machine, co-fill net, and other neural networks. The Gaussian machine based on the three parameters: a slope parameter of sigmoidal function alpha. See three parameters. One is slope parameter. The sigmoidal function is alpha. Time step delta t. Temperature capital T. Time is small t. Temperature is capital T. The step involved in the operation of Gaussian net are the following. Step 1. Compute the net input capital Xi. Step 2. Change in activity level of unit capital Xj. Apply the activation function. Next, the Gaussian machine with t is equal to 0 corresponds to the co-fill net. Boltzmann machine can be obtained by setting delta t is equal to t equal to 1 to get delta xi is equal to minus xi plus net I. The approximate Boltzmann acceptance function is obtained by integrating the Gaussian noise distribution, where xi is equal to delta c of fi. The noise which is found to weigh the logistic rather than a Gaussian distribution produces a Gaussian machine that is identical to the Boltzmann machine. Okay. Metropolis acceptance function. Gaussian function బాగా నేర్చుకోవాలండి మొత్తానికి. Boltzmann function బాగా తెలియాలి. Cauchy machine అంటే ఏంటో కూడా తెలియాలి of course. What is this Cauchy machine? Concept చాలా క్లియర్ గా తెలియాలి. Cauchy machine అంటే ఏంటో. Okay. Cauchy machine concept. Cauchy machine can be called as fast simulated annealing and is based on including more noise to be net input for increasing the likelihood of unit escaping from a neighborhood of local minimum. Larger changes in the system's configuration can be obtained to the unbounded variance of Cauchy distribution. Noise involved in Cauchy distribution is called colored noise. Noise involved in the Gaussian distribution is called white noise. Please try to understand. Noise occurred in the Cauchy distribution is called color noise. Noise involved in the Gaussian distribution is called white noise. By setting delta t is equal to t minus tau is equal to 1, Cauchy machine can be extended into the Gaussian machine. The Cauchy acceptance function can be obtained by integrating the Cauchy noise distribution. Probabilistic neural net. The probabilistic neural net is based on the idea of conventional probability theory. such as Bayesian classification and other estimators for probability density functions to construct a neural net for classification. This net instantly approximates optimal boundaries between categories. It assumes that the training data is original representative samples. The probabilistic neural net consists of two hidden layers. The first hidden layer contains a dedicated node of each training pattern, and the second hidden layer consists of dedicated land diagram మనకి మోడల్స్ నేను చాలా చూపించాను లాస్ట్ క్లాస్ లో ప్రెజెంటేషన్స్ లో ఓకే టూ హిడెన్ class and classes. That is several examples of the class. First hidden layer is connected to the single machine. Okay, unit. The second hidden layer. Just observe the input layers. When we graphical చూపిస్తాను of course. Hidden layers middle లో ఉంటాయి. Hidden layer two probabilistic neural network లో రెండు hidden layers ఉన్నాయి. Hidden layer 1, hidden layer 2, output layer. Input layer, hidden layer 1, hidden layer 2, and output layer. The algorithm for the construction of the net as follows. Step 0. For each training input parameter, x of p is equal to 1 to n. Perform steps 1 to 1 and n. 1 to 1 and 2. Create pattern unit. Zk, create layer unit 1. Weight vector for unit Zk is given by wk equal to x of p. Unit Zk is either Z class 1 unit or Z class 2 unit. Step 2. Connect the hidden layer 1 unit to the hidden layer 2 unit. X of p belongs to class 1. Then connect to the hidden layer unit Zk to the hidden layer 2 unit F1. Otherwise, connect to the hidden layer unit Zk to the hidden layer unit F2. Cascade correlation network. Cascade correlation is a network which builds its own architecture as the training progress. Figure shows the cascade correlation architecture. The network begins with some inputs and one or more output nodes. But it has hidden nodes. Each and every input is connected to every output node. There may be linear units or some nonlinear variant activation functions, such as bipolar sigmoidal activation function of the output nodes during training process. New hidden nodes are added to the network one by one. For each new hidden node, the correlation magnitude between the new nodes output and the residual error signal maximized. The connection is made to each node from each of the network's original inputs. For each I will share my presentation just 1 minute. Okay, just you can observe my presentation just 1 minute. I will share my presentation. Just listen. I will share my presentation. Just here see my share screen. ఇప్పటిదాకా నేను ప్రజెంట్ చేసిన ఇన్నోవేటివ్ టాపిక్స్ అన్ని ఉంటాయండి, ఒకసారి చూద్దాం. స్పెషల్ నెట్వర్క్స్. ఓకే, స్పెషల్ నెట్వర్క్స్. Okay, first one is simulated annealing network. See the sequence here again: Boltzmann machine, Gaussian machine, Cauchy machine, probabilistic neural network, cascade correlation network, combination network, Nico combination network, cellular neural network, optical neural networks, third generation neural networks, encoding of neurons in SNN, CNN layer sizing, neural networks, extreme learning machine model, simulated annealing networks. See the concepts what I explained. Okay, the concept, the process make metals global energy function, absolute minimum value, like that. Analogs to physical annealing behavior. Simulated annealing can make a system change higher energy, having a chance to jump from local minima to global minima. Okay, this is the equation, probability equation I explained just now. A change is represented as delta. Okay, just examine capital T, temperature. Optimal problem seeks to find some configuration parameters. Simulated annealing concept is used in statistical mechanics, is called Metropolis algorithm. That is called Metropolis algorithm. To understand this, consider a local values that I explained clearly. Okay, local minima and global minima. Neural nets, this would correspond to weights corresponds of local minimum, but this is desired function. To overcome this kind of situation, simulated annealing, okay, stone that is trapped the local minimum, global minimum. Just show the simulated annealing stone hill minimum and maximum points with the probability function. Simulated annealing stone hill. Just see this curve. The components I highlighted just now required the annealing algorithm. For annealing algorithm, the components required for the annealing algorithm. These are the components. Basic system configuration is one of the component. The other one is the move set. The other component is. The other one is cost function. Other one is a cooling schedule. This algorithm functions. The early optimization technique used in artificial neural networks is based on the Boltzmann machine. When the simulated ending process is applied W to the discrete Hopfield network. Okay? Discrete Hopfield network. Okay? Algorithm, steps, and related components. That's very important here. Okay? And I highlighted my conscious function. Conscious function. Okay, Boltzmann machine consists of set of units and a set of bidirectional connections between the pairs and the units. Machine can be used an associate memory of the units. Xi and Xi are connected. There exists a symmetry in the weight interconnections and directional nature. Maximum in CF can be obtained letting each atom to change its state 1 and 0 and 0 and 1. The change of state can be done either in parallel or sequential manner. Change of state can be in two types 1 to 0 and 0 to 1. This transaction may be either series or parallel. The consciousness change, when Xi change, okay, change is always delta. Okay, where Xi is the current state of capital X. The unit Xi are changed activations. Resulting change in CF can be obtained information in the local unit. The probabilistic network accepts a change in the state of Xi. Delta F, the change, it is represented as delta F change. Delta F change. This is the delta F change. This is the delta F change, where capital T is the temperature controlling parameter, and it will gradually decrease the CF reaches maximum value. Low value T acceptable. Okay, like this, based on formula only those parameters. Next, I highlighted architecture of Boltzmann machine. Architecture of Boltzmann machine. See this how the architecture is. I want to enhance various steps in the architecture. Testing algorithm of Boltzmann machine. See the steps. Step 0. Initialize the weights representing the constraints of the problem. Initialize the control parameter T and activate the units. Step 1, when stopping condition is false. Condition false, step 1 it will go. The algorithm will go to the logically to step 1. Step 2 is performs the 3 to 6 n square times. Step 3, integer I and j are chosen random values between 1 and n. Step 4 is calculate the change in consciousness, delta CF. Calculate the probability of acceptance is step 5. Step 6 is decide whether to accept the change or not. Whether to accept the change or not. R less than AF, accept the change. R greater than or equal to AF, reject the change. Okay, this is the change. This is the main function. Just see the main function. Probability of acceptance change in state. What is that function meaning? Probability acceptance in change in state. This is the function. On this function, this is the formula. In this, the two conditions can understand easily the change. R greater than or equal to F, reject the change. Reject the change. Reduce the control parameter capital T. Step 8 is test for stopping condition. If the temperature reaches a specified value, there is a change in state for specified number of approaches, then stop the else continue. Okay, Gaussian machine. Gaussian machine is one of the includes Boltzmann machine, co-field net, and other neural networks. Okay, this is the concept here, Gaussian machine. Gaussian machine is one which includes Boltzmann machine, co-field net, and other neural networks. The Gaussian machine is based on the three parameters. What are those two parameters? Slope parameter, sigmoidal function, alpha. Time, step delta t. Temperature capital T. Step 1, compute the input to xi. Okay, this is the step 1. Step 2, change the activity level unit xi, xj. Apply the activation function, algorithm steps there. Where the step function corresponding to alpha is equal to infinity. The Gaussian machine T is equal to 0 corresponds to whole-field net. The Boltzmann machine is obtained by setting delta T is equal to 1 to get. The approximate Boltzmann acceptance function is obtained by integrating the Gaussian noise distribution. Xi is equal to delta C of f of I. The noise which is found to obey logistic rather than a Gaussian distribution produces a Gaussian machine that is identical to Boltzmann machine having metropolis acceptance function. Okay. Cauchy machine. One more topic in this session is Cauchy machine can be called as fast simulated annealing. It is called, the concept is itself, it is a fast simulated annealing. Cauchy machine is a fast simulated annealing. And it is based on including more noise to net input for increasing likelihood of a unit escaping from a neighbor of a local minimum. Larger changes in the system's configuration can be obtained. Understand the variance of Cauchy distribution. Noise involved in the Cauchy distribution is called color noise. Please try to understand. Noise involved in the Cauchy distribution is called color noise. The noise involved in the Gaussian distribution is called white noise. By setting delta t is equal to tau is equal to 1, Cauchy machine can be extended into Gaussian machine. The Cauchy acceptance function can be obtained by integrating the Cauchy noise. Probabilistic neural net. The probabilistic neural net is based on the idea of conventional probability theory, such as Bayesian classification and other estimations, probability density functions, to construct a neural net for classification. This net is instantly approximate optimal boundaries between categories. Okay, you see the probabilistic neural network. I want to enhance. Just see this network. Input layer. Just now I explained the concepts. Just see that diagrammatically. How the hidden layer 1 is structured, how the hidden layer 2 is structured, how the output layer is. Okay, how they are structured. Probability density function to construct a neural net for classification. This net instantly approximates optimal boundaries between categories. It assumes that training data are original representative samples. First hidden layer contains a dedicated node for each training pattern P. Second hidden layer consists of dedicated node for each class. The two hidden layers are connected on a class by class basis. That is several examples class. First hidden layer is connected to single machine unit. Secondly, hidden layer, the algorithm for construction of net as follows. Step 0. For each training input pattern x of p is equal to p is equal to 1 to p. Perform steps 1 and 2. Step 1. Create a pattern unit zk. Okay. Step 2. Connect hidden layer 1. Hidden layer 2. Okay. Cascade correlation network. This is the last topic in this presentation. Okay. You understand these concepts, that's enough. You can easily write on the examination. నేను ప్రాక్టికల్ రెండేళ్ళు చెప్తున్నాను కాబట్టి మీరు ఈజీగా అండర్స్టాండ్ చేసుకోగలరు. ఎగ్జామినేషన్లో కూడా ఈజీగా రాయగలరు. నో డౌట్ ఆన్ దట్. ఓకే, జస్ట్ నా కీవర్డ్స్ చూసుకుంటే మనం లెవెల్ ఆఫ్ ఎంటెక్ కాబట్టి మిగతావన్నీ కూడా మనం సొంతగా రాసుకోవచ్చు. డయాగ్రామ్స్ని బేసిస్గా తీసుకోవాలి. దేనిలో చూసుకున్నా మనకి ఇన్పుట్ లేరు, హిడెన్ లేరు, అవుట్పుట్ లేరు, మెయిన్ ఆర్కిటెక్చర్ చూసుకున్నాం. అల్గారిథమ్స్ కూడా స్టెప్స్ కామన్ ఉంటాయండి, జాగ్రత్తగా గ్రాఫ్ చేసుకుంటాయి. మనం లాజిక్ని జాగ్రత్తగా గ్రాఫ్ చేసుకోవాలంటే. ఓకే, క్యాస్కేడ్ కొరిలేషన్ నెట్వర్క్ విచ్ బిల్డ్స్ ఓన్ ఆర్కిటెక్చర్ ఇన్ ద ట్రైనింగ్ ప్రాసెస్. Cascade correlation architecture again we have to learn. Network begins with some inputs and one or more output nodes. It has hidden nodes. Each and every input is connected to every output node. There may be linear units or some nonlinear activation function, bipolar sigmoidal activation function, and other output nodes during the training process. New hidden nodes are added to the network one by one. For each new hidden node, the correlation magnitude between the new node's output and residual error signal maximized. The connection is made each node from each of the network's original inputs and also from every processing hidden node during time when the node is being added to the network. Okay, input weights of the hidden nodes are frozen. Only output connections are trained repetitively. This is the thing. How they are connected now. Input, hidden layers. ఇందులో చూసుకుని అవే కామన్ ఉంటాయండి. ఇప్పుడు అదే నేను హైలైట్ చేస్తూ వచ్చాను. అవుట్పుట్ నోట్స్, ఇవి నోట్స్ హిడెన్ లేయర్కి ఎలా కనెక్ట్ అయ్యాయి, ఇన్పుట్ లేయర్ బేసిస్ ఎలా ఉంది. In cascade network architecture, sum of all incoming activities, the rectangular box connections, frozen, zero connections are trained continuously. In the beginning of training, there are no hidden nodes. The network is trained over a complex training set. Since there is no hidden node, a simple learning rule is used for training. Certain number of training cycles, significant error reduction, and final error obtained here unsatisfactory. We try to reduce residual errors further by adding a new hidden layer mode. Then errors will be reduced, they need to go to the satisfaction state. And the hidden layers are important. Errors తగ్గుతాయి. For performing a task, we begin set for performing a task, one task. Okay. Some withdraw buffering rule is used for training the cycles. There is no significant error reduction and final error is unsatisfactory. We try to reduce the residual errors by adding new hidden layer mode. Performing the task. We begin with a candidate node and receives trainable input connections from the network's external inputs. From all pre-existing hidden nodes, the output of this candidate node is not yet connected to the activate network. After this, we run several number of approaches for training set. We adjust candidate's node input weights after approach to maximize the value. Where I is the network output at error is measured, jth remaining pattern, the candidate node's output value. E0 is the residual output error mode at node 0. Okay, and the arranged overall patterns, the averaged overall patterns, the value C measures correlation between the candidate's nodes output value and the calculated residual output error. For maximizing C gradual, okay, the partial derivative we will use. Dou C by double Wi, sigma j comma I, alpha I, okay, E j comma I minus E bar I, dj, like that. Where alpha is the sign of correlation between the candidate's value and the output dj, the derived for pattern candidate's nodes activation. With respect to some of the inputs, the input candidate node receives from node M for pattern J when gradient is calculated to perform gradient ascent to maximize. As we are training only single layer of weights, simple delta training rule can be applied. When C stops improving again, new candidate can be brought in as a node activate network. And input weight present. Once again, all the output weights are trained and delta learning rule as done by previously. These are the steps here. Okay. Congruent network. What are the various steps? Here xn from cell x capital X to y, we reinforce if and only if the following two conditions are true. Cell x pre-symptomatic cell fights, none of post-symptomatic cell present near cell y, fight stronger than y. The model developed by Fukushima was called congruent successor. The congruent network is a self-organizing multi-layer neural network. Okay, should learn up to this. Is a self-organizing multi-layer neural network. You can understand up to this. Remaining steps I will continue in the next presentation. I want to stop here. Okay, just understand up to this. Okay, thank you for all cooperation. నేను చెప్పిన ప్రతి పాయింట్కి సిగ్నిఫికెన్స్ ఉందండి ప్రాక్టికల్గా, అన్ని ప్రాక్టికల్ ఓరియంటెడ్ పాయింట్స్. నేను మల్టీ లేయర్ న్యూరల్ నెట్వర్క్ వరకు ఎక్స్ప్లెయిన్ చేశాను ఈ క్లాస్లో. న్యూరల్ నెట్వర్క్స్ ఏంటి, డిఫరెంట్ ఫిజికల్ లేయర్ నోడ్స్ ఏంటి, ఆ నోడ్స్ ఎట్లా కనెక్ట్ అయ్యింది, ఆ నోడ్స్ యొక్క మల్టీ లేయర్ నెట్వర్క్స్ ఎట్లా ఉన్నాయి, ఓకే, అవి ఏ విధంగా ఇదిగా ఉన్నాయి, వాటి డిఫరెంట్ అల్గారిథమ్స్ ఏంటి, స్టెప్స్ ఏంటి, ఫంక్షన్స్ ఏంటి, ఇవన్నీ హైలైట్ చేసుకుంటూ వచ్చామండి ప్రతి కూడా. ఓకే, సో ఎంత మనకి ఎక్కడ దొరకని ఇన్ఫర్మేషన్ కూడా ప్రాక్టికల్ ఓరియంటెడ్లో నేను వర్క్ చేసిన దాంట్లో కూడా యాడప్ట్ చేసుకుని మీరు బెనిఫిట్ అవ్వాలని ఇంకా మోర్ ఇన్ఫర్మేషన్ యాడ్ చేసుకుని మనం చెప్తూ వచ్చాం. కీవర్డ్స్ జాగ్రత్తగా మిస్ అవ్వకుండా చూసుకుని మనం మ్యాథ్స్ ఓన్గా రాయడానికి ట్రై చేయాలి. ఈ కీవర్డ్స్ నేను పోస్ట్ చేసిన ప్రతి పాయింట్ ఇంపార్టెంట్, ఇవి ఉంటే చాలా మన మార్క్స్ వచ్చి ఉంటాయి. కానీ నేను నాలెడ్జ్కి కూడా ఎక్కువ ఇంపార్టెన్స్ ఇస్తున్నాను. వన్స్ యూ అబ్జర్వ్, ఓకే, కీవర్డ్స్ హార్ట్ ఆఫ్ ద ప్రాబ్లమ్ ఆఫ్ ద స్ట్రక్చర్. వీటితో మన అసైన్మెంట్స్ చేసుకుంటూ రావచ్చు. ఓకే, అబ్జర్వ్ చేస్తే ఒక్కొక్క పాయింట్కి ఎంత ఇంపార్టెన్స్ ఉందో మీకు తెలుస్తుంది. ఓకే, ఒక్కొక్క పాయింట్కి అంత ఇంపార్టెన్స్ ఉన్నాయి. ఓకే, జస్ట్ జాగ్రత్తగా ఎగ్జామిన్ చేద్దాం, నేను చెప్పిన జాగ్రత్తగా చూద్దాం. ఓకే, టు అక్వైర్ ద మోర్ నాలెడ్జ్. ఓకే, నేను మార్క్స్కి ఎలా ఈజీగా సెక్యూర్ చేసుకోవాలో చెప్పాను, కీవర్డ్స్ మిస్ అవ్వకుండా ఎగ్జామినేషన్ ఎలా రాసుకోవాలో కూడా చెప్పాను, మీకు డయాగ్రామ్స్ అల్గారిథమ్స్ ఎంత ఇంపార్టెంటో చెప్తూ వచ్చాను, స్టెప్స్ ఎంత జాగ్రత్తగా రాసుకోవాలో చెప్పాను, సింగిల్ లేయర్ నెట్వర్క్కి మల్టీ లేయర్ నెట్వర్క్స్ డిఫరెన్సెస్ చూసుకోవాలి, దేర్ స్టెప్స్ క్లియర్గా ఐడెంటిఫై చేస్తూ వచ్చానండి. ఓకే, జాగ్రత్తగా ఎగ్జామిన్ చేయండి. ఓకే, సో ఐ విల్ కంటిన్యూ ద నెక్స్ట్ సీక్వెన్స్ కాన్సెప్ట్స్ ఇన్ మై నెక్స్ట్ ప్రజెంటేషన్. ఓకే, యూ కెన్ నా స్ట్రక్చర్ మిస్ అవ్వకుండా జాగ్రత్తగా వెళ్ళండి. ఓకేనమ్మా, దట్ ఈస్ మోస్ట్ ఇంపార్టెంట్. ఓకే, సో ఒకసారి నా కీవర్డ్స్ పరిచయం కూడా చేసుకోండి, ఫస్ట్ నుంచి నేను పోస్ట్ చేస్తున్నాను. ఎక్కడ మిస్ అవ్వకూడదు, డయాగ్రామ్స్ నోట్స్ కూడా ఎక్కడ మిస్ అవుతుంది. దేనికైనా కామన్ పాయింట్స్ ఇన్పుట్ లేయర్, అవుట్పుట్ లేయర్, హిడెన్ లేయర్ ఏం చేస్తుంది, హిడెన్ లేయర్ 1 and 2 ఉన్నాయి, కొన్నిటి హిడెన్ లేయర్ ఒకటే ఉంది, ఎందుకుంది, వాటిలో కాన్సెప్ట్స్ ఏంటి, డయాగ్రామ్ని బట్టి నేర్చుకోవాలి. డయాగ్రామ్ ఈజ్ హార్ట్ ఆఫ్ ద టాపిక్. ఆఫ్ కోర్స్ డయాగ్రామ్ మనకి క్లియర్గా ఉంది అంటే మనకి దానికి సంబంధించినంత కూడా క్లియర్గా మ్యాపింగ్ వచ్చేసేయాలి. డయాగ్రామ్ బట్టి డయాగ్రామ్ ఎగ్జామినేషన్ చేయాలి. ఈ స్టేజ్ దాకా మనం నెక్స్ట్ స్టేజ్ దాకా వచ్చింది. ఎందుకంటే నేను ఎంతో హార్డ్ వర్క్ చేసి మోస్ట్ సింప్లిఫైడ్ ఇన్ఫర్మేషన్ ఐఎమ్ గివింగ్ టు ఆల్. యూ కెన్ యూటిలైజ్ అండ్ ట్రై టు పుట్ ఇన్ యువర్ ఓన్. అది మన చేతుల్లో ఉంది. ఓకే, థ్యాంక్ యూ అన్నారు. థ్యాంక్ యూ.